Greetings. So today's class under embedded programming will see the difference between C and embedded C. So what is C? C is a general purpose programming language and was developed by Dennis Ritchie in 1972. So it's again a structured programming. It's easy to learn and widely used, and it's again a platform independent. It's used for developing operating system, application and utilities. Looking into the examples, we have Windows, Linux applications, database software, compilers, games, all based on C. And what is embedded C? Embedded C is an extension of C programming language, and this is specifically designed for embedded system. And embedded C is used to program microcontrollers and microprocessors. It interacts directly with the hardware peripherals. And we have an efficient memory and resource management while using embedded C when compared to that of the assembly language. So some examples of embedded microcontrollers are washing machine, smart TV, automotive ECU, medical devices, IoT devices, mainly programmed using embedded C. So already in the last classes we have seen some part on embedded C and C. So that's all with an introduction PPT. So now this class we are looking mainly on the C and embedded C's difference. So C versus embedded C, what is the basic difference? You can see it's general purpose. To the left we have C is general purpose programming, embedded C is used for embedded system. It runs on computers, then embedded C runs on microcontrollers. And again C is hardware independent, where when you write embedded program in embedded C, it is hardware dependent. Based on a hardware you will be writing. And this has got standard libraries, and this has got, the embedded C has got device specific libraries. And C, large memory available, but in case of embedded C, you know it's all resource constrained devices. You have only limited memory. So coming to the other difference based on execution environment, C runs under an operating system, uses processor and system memory. It depends on the operating system services, whereas embedded C execute directly on the hardware, usually runs without an operating system. It controls hardware in real time. So looking into the examples is reading a switch, blink an LED, reading a temperature sensors. All these will be a simple simulation software you can run with. So the next difference, the category for the difference is memory and resource usage. When you look into the C, C takes large memory and storage. It's dynamic memory allocation, where the location data can be stored anywhere. Less concern about memory optimization. So reducing the memory is not a very big concern in the case of using a C. Whereas in embedded C you have only limited RAM, and you have a flash memory where to write the programs. Memory optimization is very important, and dynamic memory allocation is often avoided because you may have some kind of erasers or some kind of a problem hazards that's leading into when it is stored in any other location. So the dynamic memory allocation is often avoided, and the efficient code is very essential when you talk about the embedded C. Coming to the hardware interaction, C, it does not directly access the hardware. As we have already seen, it's hardware independent. It directly not depend on the hardware, and mainly it uses operating system functions. Whereas in embedded C, it directly accesses the hardware registers. You know that you would have studied already. We have studied PIC 8051, where you can see that all the working registers, or else the accumulator, all these have been accessed. So this should not cannot happen in the case of a C. You don't have any hardware registers to be accessed, whereas in case of embedded C, it's again it's hardware dependent. You will be writing the program for a particular hardware. So there you can access the hardware registers, and you can control all the peripherals like the general purpose input output, ADC, UART, SPI, I2C, timers, pulse width modulators, so on, because this is embedded systems. So any kind of external devices or external peripherals can be controlled. So you can see as an example you have Tri-State B, where this is again where you are configuring your port B as a output port. So you have a control on the extra input output devices, and again a port B is given some data. So coming to the program structure, here you can see on the to the left you have a C program, and to the right you have a embedded program. So embedded C program. So to the C program, you can see here is normal standard IO.header files. Whereas in the case of an embedded C program, you can see whatever microcontroller you're using, that header file will be added up, has to be included. So in this case it's a PIC microcontroller. You can say PI184F458 dot header file. So not all compilers can work like this. So but to make you understand, we have given stdioh.h, and here it's a microcontroller with a header file. And then again it starts with int main, where here in the case of embedded C it's void main, and here you can see just a print and return. But here you can see it's Tri-State B is equal to 0. It means that a particular port is made 0, an output port, and while of 1 is a must in the case of an embedded C, because any program should run continuously. So and you can see port B is given a value of FF. So you can see the format, both the format runs in a different way, whereas in the case of C program it runs on a computer, whereas in an embedded C program it runs on a microcontroller. So looking into the comparison, you can see the features are given to the leftmost. You have a purpose, you have platform, hardware access, operating system, memory, libraries, execution and applications. Whereas in the C programmer it's general programming, and in embedded C it's embedded systems. Here it's computer, there it's microcontroller. Here the hardware access is not needed, but there hardware access is needed. The operating system is required. There it's in embedded C is not usually required, and the memory requirement is large in C, whereas there in case of embedded C it's limited. Libraries are standard, that are device specific. Execution starts and ends, but here it runs continuously. For example, in case of application it's software dependent. Here it is real time control. Thank you.